Okay, so for let me take that point. So x equal to a. From this x minus a equal to 0, that means y is 0 here. So this is x equal to a. At this point, the curve is being intersected. Okay, so if I draw x-axis, y-axis, sorry, parallel to the this at this line, y is 0, y is 0 here. So this is the original y-axis. This is the original y-axis. Y dash, this is x dash, this is x-axis. Now, okay, so at this point, what we see here, that this y square equal to 0, if x equal to 0, so what is the curve here? Because x equal to a, x minus a equal to 0, if I equate the coefficients of this equation, x equal to 0 and x minus a equal to 0, okay, so this x minus a equal to 0, in that equation, so x equal to a, that means at x equal to a, if I take, okay, so x equal to a, we have taken here, with the x equal to a 0 point. Then the curve will be if we take, this is x equal to a. This line is x equal to a here. Sorry, y equal to a. With y equal to a, we have taken y square equal to 0, or y square equal to a square. If I take x upon x equal to a, y equal to plus minus a. Y equal to plus minus a. So the curve is okay. The curve is, we're talking about the curve is what you call symmetric to the axis of x. So this curve will be like this. Okay, at this point, x equal to y equal to plus minus a here we have taken. So this is y equal to minus a, and this line this all this solved, and y equal to a here. So from where this we solve this equation from the given equation. So we have to solve here that y square minus a square equal to 0, y equal to plus minus a. These two equations were obtained from the given equation after changing this, putting x equal to a. So this was y into here x minus a, and here it was a square into a. Okay, it was x only, was x plus a cancel x into a square. Then we equated the coefficient, then we take the x coefficient common, so y square minus a square, it was there. So from the given equation I just forgot about. From there we had to obtain y square minus a equal to 0. This was the equation of the tangents here. Okay. Now these two tangents, which are asymptotes in this case, working as asymptotes. These are two lines, y equal to plus minus a. Y equal to minus a is this line, okay, parallel to the axis of y. So at this line, y equal to minus a, this is minus a here. Y equal to minus a, this is y equal to plus a. Within these two lines, the curve is, we will obtain this curve similar, okay, which is just symmetric to the axis of x. This is one of the curve because at a0, the curve is intersecting at this point a0 to the axis of x. Then we obtained these two lines y equal to plus minus a, the given equation. And then from this equation we see that if x is increased or x tends to 0, suppose, then this is infinity, so y tends to infinity. X tends to 0, y tends to infinity here. So this is y tends to infinity. Sorry, this is not the equation. Now in this case, this is the equation a0. So this kind of curve will be there. This is one of the curve here. How this is obtained, y equal to plus minus, these are two tangents here. Now second point is, when below this, when y is, okay, this is origin here. Below this origin or beyond this origin, when x tends to, x is greater than 0, or sorry, less than 0 here, it will be negative, y will not exist. okay, during this period, but we have to take the infinite value to when x tends to 0, y tends to infinity. So this is y tends to infinity at x equal to 0, and then this when x tends to infinity, negative infinity, minus infinity, y tends to 0 here. This is one of the curve here. Okay. Then second curve is this. So this is symmetric to the axis of x. These are two curves we have obtained here. How this is obtained? Because when x tends to infinity, y tends to 0. X tends to infinity, negative infinity. If I take minus infinity, this is also minus infinity. It will be negative. Then y square tends to 0. Because this is infinity 0. Something upon infinity 0. This is tends to 0. Okay, so y tends to infinity, x tends to 0. At the point of this, infinity, y tends to 0. And at x tends to 0, y tends to infinity. So this is the asymptotes, the two asymptotes which we are taking to this axis of y, which meeting to the axis of y. This is one point here, and second curve is this, because at a 0 point the curve was intersecting, curve was crossing the axis of x at e0 point. Then we found out that there are two tangent lines, okay, the two tangents or asymptotes here, okay, along which the curve is going. This curve is also passing when x increases more than a, or if I take 2a, then y is this value. On this equation we can solve x equal to 2a, suppose 2a, a upon 2a, we consider out is aq. In terms of aq, we will obtain some values. From this equation only these values are obtained, negative and positive. This is y plus minus, let me write here, or y is equal to plus minus a under root x minus a divided by under root x. Similar values. If I substitute here, this curve is obtained from this figure here. How? Well, if I put x equal to 2a, suppose this is a, this is 2a plus 2a. 2a means under root a, this is under root 2a, under root 2 into a cancelled out. So this is a upon root 2. A upon root 2, then put value of root 2. So this is something in terms of a. So this will be lesser than a. Up to this point, this is y equal to a. The value obtained will be a upon under root 2. That means lesser value than 1. So this is up to this point. And 2a, this point. Again, it will be lesser. This is 3a minus a, this is under root 3a. Further lesser value because this is 3 times in the denominator. So the lesser value, this curve will intersect, will meet up to the infinity. So from this value, we have obtained two values, one negative, another positive. This curve is obtained, okay, by substituting different value of x. X equal to a is okay, 2a, 3a, because at a minus a is 0, is 0 here, y 0. At x equal to 2a, y will be something negative, positive and negative. Y equal to 3a, then this point, so it will meet at infinity. Okay, so this is one curve here. Second curve, this at the asymptotes when y tends to negative, lesser than 0, negative value, then y tends to this negative, y will be positive, but it tends to infinity. It tends to 0, y tends to infinity. When x tends to infinity, y tends to 0. So in this way, y tends to 0 means this asymptote will meet the x-axis, because y is 0, but at infinity. Similar curve here, plus minus x. From this only, we have obtained the two shapes here. If I put x equal to more than a, or x less than 0, because within 0 to a, there is no curve doesn't exist. Only beyond these two limits, x equal to a and x equal to 0, we are having the curves. This curve is obtained only from this one when we tend to infinity, 0, infinity, 0, infinity. Okay, so y tends to infinity, or x tends to 0, and x tends to infinity, negative infinity, y tends to 0. So this is what we are taking these two figures here. Second question, okay, so symmetric about axis of x. we have already clarified, is even, so curve will be symmetric about axis of x that we have written down. So axis of x, these two curves are okay. So very important question is this, but only from this figure, this equation we have obtained these values. And this y square minus a square, this value we obtained from after shifting the origin to a0. Putting in this equation in place of x a0, we will obtain this solution y minus a square equal 0. Then we will obtain this. So this is the question number 8th B part. Both the questions of 8 have been solved. Now let me take 9th question. Again, question number 9th is ready. Let me check whether question is of similar type or of different type. Now question number 9th here. This is 15, 14. 9th question is trace the curve. Okay. Let me take the 9th question here. The question number 9, let me change the marker. Question number 9 is the question number 9 here. It says that trace the curve x into y square plus, where is y square plus 4a square is equal to 8aq. 8aq, okay, x into y square plus 4a square is equal to 8aq. This is equation number 1. What we see here, so here y is even, so curve will be symmetric to the axis of x. Let me write here solution. Again we find here, first point here, the curve is symmetric. The curve is symmetric about axis of x. About the axis of x. Why? Because as y has even powers. Y has even powers. If y has even powers, then x will be the symmetric line. Okay, the curve will be symmetric by axis or about x-axis. If y is even, x-axis is a symmetric line. Or if x is even, then y will be symmetric line. Curve will be symmetric about y-axis in that situation. But in this case, x is x, this x only, no other power. So x is not even power. So this means only y square is there. Y is even power. Because of that, the curve will be symmetric about x-axis. This is the first point. Second point, what we do here, we see whether 0 is not line. Why? Because this constant term is there. Origin is not the curve is not passing through the origin. Curve will not pass through the origin. Will not pass through the origin. One point. Third point, what we do? Now we substitute y equal to 0. Putting y equal to 0. Y equal to 0 in first. What we get? We get y equal to 0 here. This is 4a square into x equal to 8a cube, or x equal to 8a cube upon 4a square. That means 2a. 4 2 and this is a only 2a. X equal to 2, so the point is 2a0. 2a0 is the new origin. Shifting the origin to this point, so curve will cross the axis of x at this point. So the curve will cross. Let me write here. The curve will cross the axis of x. The axis of x at 2a0. Shifting the origin. Shifting the origin to 2a0. We get what do we get here? So putting in place of x plus 2a, so take x plus 2a in the first equation, x plus 2a. Okay, within bracket it is only y square, no change because y is 0 here. Y square plus 4a square equal to 8a cube. Okay, if I divide it by this, it will be y square is equal to 8a cube divided by x plus 2a minus 4a square. So these are the two values here, and 8a cube upon this. So if I put x equal to lesser than this 2a value, sorry, more than 2a in negative terms, in that situation y square will be negative. Okay, so or x equal to 0, then this value will be negative because then 2a 8a cube upon 2a. If x equal to 0, if I substitute, then this will be negative value. Then x equal to 0, so this will be 4a square minus 4a square, y will be 0, 0, 0. And another point here, after shifting this point, we have obtained this equation, x plus 2a equal to, okay, so here if I equate the question, this is x equal to 0. X equal to 0, let me write here. So this x into 4a equal to 0, equating the smallest degree term from this equation. Now smallest degree term equal to 0. That means the smallest term x into 4a square will be there, because that will be only the power. This is y square into some 2a or y square into x, that is the smallest degree term, but only x into 4a square, that means x equal to 0. So x equal to 0, that means x is 0 at y-axis. New origin or new asymptote through this line, tangent line, or will be y-axis. New y-axis at this point 2a 0 will be the axis of this point, okay, along which the curve will be, asymptote will be found out. So the new y-axis, so the new y-axis, okay, parallel to the old one, will be tangent or asymptote, will be a tangent or asymptote to the curve at this point y is a0. Let me draw the curve here. Okay, and that equation was here x equal to minus 2a. So beyond 2a, okay, there is no curve. Curve will not be found beyond 2a. Okay, and within or beyond 0. Why? Because there is x equal to 0 here. But I will just solve that later. Let me first show the curve. This is x-axis, this is x dash axis, y and y dash axis. Now in this case, let me take this twice here. 2a 0 is the new point. Now the curve is passing through this point here. Okay, and at this point y is equal to 0 if I take. Okay, so the new y-axis at this point, the curve is, we have to take like this. This is the curve possible. Y, and at this point y-axis, at this point the new y-axis, this one, which is parallel to the old one, is the tangent line to this curve at this point. This is a tangent line, or we may say asymptote here, but this is not asymptote. Asymptote is this. This y-axis is the asymptote for this point. Okay, so this is the required curve here. By this curve, 2a 0 is the point at which the curve intersect the axis of x. Okay, at this point, the new y-axis is the tangent line at this point that we have found out, and then we saw that when x tends to 0, y tends to infinity. X tends to 0, y tends to infinity. If I take from this equation, so x upon x, if I take from this only, y square, okay, is equal to 8a upon x, this value, minus 4a square. Okay, if I solve this for y, this is y square equal to x. If x tends to infinity, y tends to 0. This is 0 here. X tends to infinity, y tends to 0, because this infinity will be infinity. That y tends to infinity here. X tends to 0 if I take. X tends to 0, y tends to infinity, plus minus, because y here equal to plus minus this value under root 8 means 2 under root 2 into a cube 3 by 2. Okay, divided by under root x, this value, and this minus 4a is just neglect, or we can just add in this case, or take the square root of this whole value. Take the square root of this whole value. This is y equal to plus minus. Okay, so from this we can find here that x tends to 0 for this given equation. Y tends to infinity. So x tends to 0, y tends to infinity, plus minus infinity. Because of that, this curve is there. Okay, this is symmetric for this asymptote is passing through, or is parallel to this, or meeting the axis of y at the infinity. So this is a curve required. Okay, at this point we have found that the curve is crossing the x-axis at this point 0, at which the y-axis, this new y-axis, is the tangent line that we have calculated. Then we calculated that as x tends to 0, x tends to 0 here. When x tends to 0, y tends to infinity. At this different point we can calculate here. Suppose x equal to here. This is twice a. Suppose a, then the point will be there plus minus value. In the same equation, if we substitute x equal to 2a, x equal to a, sorry, x equal to a, so this is 8a square minus 4a square, sorry, this is 8a square minus 4a square, 4a square, so 2 under root a we will obtain. 2 under root a plus minus, this is 2 under root a in this case. Y value is so plus 2a and minus 2a, so this is the point. In this way, this curve will be obtained. Only from this equation we can find out value of y. So this curve is obtained by this, but this origin, after shifting the origin to 2 at 0 point, taking the crossing point. So this is the curve, 9th question here. Let me take, this is symmetric to the axis of x, as we found out. Y square is even point. This is x-axis. The curve is symmetric to the axis of x. Okay, this is question number 9th here. Now let me talk about 10th question. We'll go 10th question here now. Question number 10th. Now it says, question number 10 says, trace the curve y square into x square minus 1 equal to x. This is the first equation. Solution here. Now what we see here x square and y square is even. So curve will be symmetric to the axis of x. First one is here. Curve will be symmetric about axis of x. About axis of x. Why? Because y is only even power, x is single power, x square. So about x-axis, about axis of x, as y is even power. Is even power. First point. Second point. Does it pass through the origin? No. No independent term. It is not passing through the origin. It is not passing through the origin. Passing through the origin. Okay, third point, what we did, put y equal to 0. at y equal to 0, we obtain from this equation x equal to 0. Because if I put y equal to 0, okay, so x equal to 0. Y equal to, if I put x upon x square minus 1, y equal to 0, that means this equation will give us, if I put x equal to 0, even then y equal to 0. So x equal to 0 and 0. It means 0, 0 is the point at which the curve is intersecting. It means 0, 0 lying on the given curve. Okay, so solving this equation for y then, because both points are there, 0, 0 is lying on the curve in this case. For y square, here there is no constant term, is passing through, I'm sorry. There is no constant term, I'm sorry, what I've written down here. It's not passing through, but it is passing through the origin. I'm sorry. It will pass through because no constant term is there. I think this minus 1. I'm sorry, it will pass through the origin. It will pass through the origin. Sorry. Because there is no constant term. This 1 is multiplied by square, I'm sorry, through the origin. This we have already obtained from this 0, 0. 0 is the origin here. At origin, the curve is, okay, crossing the origin or passing through the origin. This is given here. Then, solving this for y, the equation y square equal to x upon x square minus 1. The coefficient of then, okay, y square, if we equate the x equal to 0, so y axis is the tangent line, or okay, along about the y axis it would be, sorry, axis it would be symmetric, no doubt. So equating from that equation y square equal to, from first solving for y, we get here y square is equal to x upon x square minus 1. Here, if I x equal to plus minus 1, if I put here x, so x must be less than 1 or greater than minus 1. Okay, x here cannot be equal to 1 because at x equal to 1 by infinity is infinity plus 1 is infinity, but x equal to 1 by infinite. Okay, so and x equal to 0, if I take, then it is negative. Sorry, it is 0 here. If x is lesser than, numerically lesser than minus 1, then it will be negative here. Then y is not defined. It means by x lying between minus 1 to 0 or 0 to minus 1. Then this curve is not defined because at minus 1, in the numerator we are having x here. If I put value of x square is lesser than minus 1, that means it will be negative in that situation. For value of x lesser than minus 1, the curve is negative. So it means the curve beyond minus 1 is not lying. The curve beyond x equal to minus 1 will not exist. Will not exist. The curve will exist only between minus 1 to 0. Okay, minus 1 to 0, we have to take the curve here. Minus 1 to 0, x equal to minus 1. Beyond minus 1 to 0, the curve is lying. X equal to plus minus 1. So in x equal to plus minus 1 also, we take here, the curve is lying, and let this minus 1 is plus 1. This is minus 1, 0. So beyond the, okay, this is the line, this is the origin O, x-axis, x-axis. The curve is passing through the origin. We can take like this. This is one of the curves here. Because as x tend to minus 1, x tend to this is minus 1 and 0. by tends to infinity. And extend to minus 1 by tends to infinity. This is the asymptote here. This is the x equal to minus 1 line. X equal to minus 1, this is the line here. Okay. X equal to plus 1, this line is also there. X equal to plus 1, this is the line, suppose. Here it is x equal to 1. Beyond this line also, the curve will be there. So this is one of the curves, because as extend to x is extend to 0, this is 0 here, by tends to 0, but extend to infinity, by tends to 0. So extend to extend to, sorry, minus 1 here, minus 1, or any, suppose x equal to 1 here, x equal to 1, x equal to, the value of this is suppose minus 1, then extend to infinity, because it must be 0 then. So 0 upon something upon 0 is, if x is 1, at this point minus 1 or plus 1, whatever, at plus 1 and minus 1, the curve is infinite. So this is how we have to talk about. Again, this at this point also, the curve is at x equal to 1 also, this is 0, something from 0 by tends to infinity. This is the curve here. We can take another curve. First curve is this, okay, because it passes to the origin. Next curve is, in that situation, that we have to take x equal to 1. So what is the asymptotes here? As extend to beyond 1 or more than 1, then the asymptotes will be as x increases to plus infinity, x into plus infinity, by tends to 0. Okay, or by also tends to infinity, because in the numerator we are having infinity. This is infinity. So this is plus minus, because this is plus minus and y square is there. Y plus minus this value on root of this. So when extend to infinity, y also tends to infinity, because in the numerator we are having infinity. This is 0, undoubtedly, but this is infinity, it tends to infinity. Plus minus infinity, so this is the curve here. This is another asymptote. Another curve is this. Beyond x equal to 1, as x increases, or infinity, y is infinity. Or when extend to 1, then y is infinity. Extend to 1, by infinity. Extend to infinity, by tends to 0. Extend to infinity, by tends to 0. Extend to infinity, by tends to 0. Y will meet at the, sorry, x-axis at the infinity. This is what we have.